Hi, my name is Kailey Wong, and I'm a incoming second year at UC San Diego studying mathematics and computer science.
And my name is Urwah. I'm going into my third year at UC Davis, where I'm studying computer science. Today, Kailey and I are going to be talking about LaunchIT and the different developments and integrations we added to LaunchIT. So prior to the creation of LaunchIT, users really couldn't instantaneously allocate PDS resources for themselves. They had to create a ticket and email back and forth with our admin team in order to allocate a PDS instance. So LaunchIT began as an internship project for the 2021 Do It team and has been continued by the WEG team. It's a user-facing web application that allows users to instantaneously request and deploy persistent data services. So persistent data services include databases, message broker and queuing systems, and object storage.
So the first project I worked on for my internship was user interface design improvements for the LaunchIt application. And my goal for this UI redesign was to take the pre-existing application layout and update the user interface for LaunchIt to be more visually appealing and intuitive for users. Throughout the entire redesign process, there were a few design goals and principles I wanted to keep in mind. The first was consistency in elements like the typography, graphics, shapes, and color scheme. The second was visual clarity by creating a visual hierarchy and keeping simplicity and white space in mind. And the third was improving usability by incorporating more visual association, descriptors, animation, and responsiveness into the application. I'll point out some of these ideas in my design choices on the next slide. For the for the redesign process, I began with wireframing, which is a process where designers create outlines of their products to establish the structure and flow. And I used the design software Figma to create my wireframes. To implement these design changes on the front end, I used HTML, CSS, and the Bootstrap CSS framework. Here I've included images of the LaunchIt application interfaces before and after my redesign. In regard to the design goals and principles I mentioned earlier, for consistency, I wanted to create a brand for LaunchIt with consistent fonts, graphic styles, rounded shapes, and a blue color scheme. For visual clarity, I used colors to emphasize different sections of the page and create a visual hierarchy, also making sure to keep the design balanced with enough white space to avoid overwhelming users. And finally, for improved usability, I incorporated more graphics to improve visual association with actions, and I added descriptors such as to the catalog and dashboard buttons on the landing page to make actions clearer.
So the first project I started working on was integrating Mattermost to LaunchIt. The goal of this was to create a notification system that would help our team keep track of PDS creation and deletion. So in order to do this, I created a logging function using the Mattermost webhook and generated comprehensive logging messages that would include information such as the user who created or deleted the instance, the namespace the instance was created or deleted in, and the resource name and type of the instance. We can see at the bottom here, I have a couple of logging messages where you can see the username, the namespace, as well as the resource information. So I integrated this new logging functionality into pre-existing logging classes for PDS deletion and creation. These logging classes would log to Splunk as well as a Mongo database and now Mattermost. So Kailey and I then began working on a group namespace functionality. So prior to us implementing this, users had no real way to collaborate across projects and share their resources. So we wanted to create a way for them to collaborate. In order to do this, we started in two steps. First, we wanted to implement a feature that would allow users to view, add, and remove user roles from various projects. We also wanted users to be able to create and delete projects for collaboration purposes. On the front end, we used HTML5, Jinja, CSS3, and Bootstrap 5. On the API layer, we used OpenShift, and on the back end, we used Flask as well as Python.
So for the user roles interface, we wanted to make that accessible from two locations. The first was the dashboard with the complete list of projects a user has access to, and the second is the dashboard for that specific project. In terms of the user design, we wanted to ensure the interface was as intuitive as possible for users. And so we imitated the OpenShift interface, and this way users will be already somewhat familiar with the new feature. And we also made sure to provide lots of user action feedback, such as through displaying loading animations and success and error messages. For the project creation interface, we made that accessible just from the Workspaces dashboard, and we just used a simple user design and helped to ensure that naming conventions are followed so users don't have to worry about it.
On the back end, we added in functions to add, delete, and get a comprehensive list of user roles. We modified a pre-existing project creation function and created a new project deletion function. We did all of this using the OpenShift wrapper API to create these various requests.
To connect the front end and back end portions of this feature, we use Jinja dynamic HTML templates to display information according to the user who is logged in. And we also use the Flask web framework to collect and process a user's desired actions through forms displayed on the front end. And this includes data such as the type of action, the project, the user, and maybe the role that they're requesting the action for. And using this data, we can initiate action requests or receive information using the backend functions to the OpenShift API. In implementing these features, there was also some security and business logic we had to consider. Some examples include preventing users from adding other users to their personal projects, which might be used to store secrets, preventing users from deleting their own personal project, limiting project creation per user, which we did by checking for the number of project creation requests a user has. Also, project and user deletion sanity checks just to provide an extra layer of confirmation that the user actually wants to delete a user or a project. And finally, handling errors or invalid permissions gracefully so users don't have to guess at what might have gone wrong.
So in addition to the new functionalities we added, we also created a logging class to help us keep track of the creation and deletions of roles and projects. These logs are saved to Splunk and a Mongo database, as well as Mattermost, which we talked about a little bit earlier. We also created comprehensive test cases using PyTest to ensure adequate code coverage. We would test both successful and failed runs of our functions. So we would test with valid input to make sure that it would succeed, and invalid input to make sure that it failed, and when it failed safely.
Yeah, so these are the developments and integrations we've implemented for LaunchIT so far, and we're currently working on integration with storage grid object storage, which Ramon will talk on later. And we'd be happy to answer any questions you might have. Thank you.
When will we see this in production?
So yeah, it's going to take some time, right? So definitely, as you know, when we started last summer, the interns did a whole lift of building this application from scratch, and it took a few months after finishing. But I think they did a really great job. We just need to go through security, as you know, and make sure that everything and test. But they created some amazing tests, and I think that the LC users are going to be very happy with all of this new functionality. But definitely it is in the pipeline. We just need to go through the process of making sure that it's secure and tested. But I think that it's going to go potentially faster than the first time.
So my name is Ramon Romola, and over the course of this past summer, I think my internship theme was automating everything. Some background about me. I'm an incoming third-year student at the University of the Pacific in Stockton. I'm majoring in computer science. Some of my academic interests include machine learning, data analysis, and course automation. Personal interests of mine most notably include coding. I love coding. So my first main project over the course of this summer was web UI testing via Python. The way we did this was using the Selenium library. Some background of what we were actually testing was the front-end LaunchIT application that we've been developing And basically, Selenium is a Python library that allows us to automate and interact with websites via a driver. In this case, we're using Gecko driver, which is specific to Firefox. Here's an example of the test login function that we use to log into the LaunchIT application. So the driver just interacts with the HTML elements in the HTML, and it could click into them. It could send input and look for specific input or specific elements also. So one of the main reasons why we did this was to ultimately integrate it into our CI/CD pipeline. The issue with this that we ran into at first was LaunchIT uses a token or a RSA pin plus password authentication-based method, but we needed a token-based method for our service account to go in the CI/CD pipeline to run the test. We were able to implement this, so thankfully these tests will be ran every single time we run a new pipeline on the front end app. Here's an example of how it looks in our YAML configurations. Here's just like a visual representation of how the tests actually go through. Here we can see that the Selenium driver is going through and creating a PDS instance of a Maria database. This is just entirely visual, but in our pipeline, we have it run in a headless environment since there's no GUI in the pipeline. But next, my main project, I guess, was integrating object storage allocations via storage grid and S3 keys, which is I'll get into it right now. So what is storage grid? Storage grid is the platform that we use to store buckets in accounts that we call tenants. These buckets are, they use the S3 protocol that Amazon developed, which is a simple storage service to store objects, so files. It's basically a different way to store files as opposed to the traditional file management system. On the storage grid side, we use the tenant management API to allow for creating and deleting tenants. On the AWS or on the bucket side, we use the Boto3 Python API client to allow us to authenticate connections to the AWS buckets, or the S3 buckets, sorry. This authenticated connection allowed us to perform actions that include creating buckets, deleting buckets, looking at their files, and stuff like that. So the problem that we're really addressing here is, suppose a user wants to launch a tenant, or they want to create a tenant. They would have to call the LC hotline, which would put in a request for someone from the WEG team to make a tenant and the S3 credentials on their behalf. In this situation, nobody's really happy because the user had to wait for these tenants and the S3 credentials to access the tenant or access the buckets within the tenant. And yeah, the WEG team had to manually do it. So the answer to this is automation. That's pretty much what we did. I worked entirely on the back end, and the main issue that we had to juggle throughout the entire course of the project was the 3 different API layers that we had to work with, specifically OpenShift, Storage Grid, and the bucket Boto3 library. So we had to juggle through the various APIs and the various authentication methods that they all require. For example, on the Storage Grid side, we had to use Storage Grid credentials. On the OpenShift side, we had to use OpenShift OAuth token. And on the bucket side, that we had to use the S3 credentials that we stored within the OpenShift secrets of the user's namespace. So it was a lot of back and forth between different API layers. So to simplify everything, we actually created a intermediate LaunchIT client wrapper that facilitated the connections between each various aspect of the project. So it allowed for the creation of tenants and allowed for the creation of tenants and S3 credentials automatically. So the admin level is kind of like the scariest part because we really wanted to limit it in its abilities. So the only purpose that the admin level class serves is creating the tenant and then logging into the tenant and creating the S3 credentials. These S3 credentials are returned to the client wrapper class, and from there it is stored into the user's namespace as an OpenShift secret. And these S3 credentials allow the user to authenticate their connection to their buckets and perform actions, including creating, deleting the buckets, and looking at the files, what I said earlier. Yeah, so here's like an example code of the user level action of force deleting a bucket. So yeah. Oops. So we might ask what's next. Hopefully we can implement a GUI that will allow users to import their existing S3 keys. Pretty much, it would be pretty trivial for us to implement this feature. Since S3 keys are a thing developed by Amazon. So let's say the user has buckets in a different region, for example, Europe or something. We can allow the user to pick a specific region that they store their S3 key in, and then we would get the name of the bucket and the information of the bucket, and this will automatically create a ARN, which is a Amazon resource name that would identify where the bucket is located. And then, like I said, this would allow users to import existing buckets as opposed to transferring everything over manually. And that's pretty much it.
Hi, my name is Joseph Sam. I was working on Helm charts. A little bit about me, just a fourth year CIS student at Cal Poly Pomona. These are the relevant hobbies. Just to get into like what is a Helm chart specifically. So a Helm chart can be considered like a package manager. It's essentially like a set of files or a set of templates that get filled in based on what you enter in a values.yaml file. So the values.yaml file is essentially the source of all the other file values inside a Helm chart. So when you save your values file and run that Helm, it renders the templates into a real Kubernetes, in this case, an OpenShift manifest that get applied like any other OpenShift template that we've been consistently using as of recently. It's a lot more modular, customizable, and full-featured than these OpenShift templates, though, so that allows it a lot more usability and reusability. To get to the goal of this project, we were trying to create a Helm chart for our database services, trying to successfully integrate these Helm charts into a package registry in Gitlab so that it could be deployed as well as published and shared among other people. We were trying to deploy these Helm charts into a Quay repository, Argo CD space, and OpenShift cluster. And of course, documentation on that Helm chart. So to go into like a quick little Helm chart installation demo. So in this demo, these following points will be reviewed and covered in an effort to just understand the process that goes into creating that Helm chart. For that, it's going to be creating the Helm chart. Just like this is the very high level overview of what it is. This was, in my case, I was using MongoDB as a way to create that Helm chart and as a way to essentially, uh, because in Mongo or in the OpenShift templates, we essentially fragment the pieces that we need. So if you see right here, you see there's kind, and that has deployment config. And under here, there's a deployment config.yaml. So it was essentially a separating of the different sections of our OpenShift template, and then just divvying it up into separate YAML files. Uploading that Helm chart onto Quay, installing the Helm chart locally and in our OpenShift cluster, as well as Argo CD implementation. So we were able to get through all of that. That was just like a quick little visual demo, but I just wanted to touch upon how we were able to create that Helm chart, and as well as deploying and publishing that Helm chart into separate sections using a CI/CD pipeline in order to get that continuously integrated and deployed. And specifically, why does this matter? I'd say this matters because it's very important to just constantly bring efficiency to our workflow and bring efficiency to the tech stack, and allow for more reusability, just in case our applications become more complex. I'd say that OpenShift templates, does a decent um, it does decently at handling complex and just like scaling up, but I'd say that Helm, since it's the de facto Kubernetes templating language, it was practically designed to be scaled up, be scaled down. It just offers a lot more complexity, and it offers a lot more durability in terms of handling complex applications or simple applications. So yeah, I'd say that um, overall, Helm version 3 specifically has been a much more full-featured and modular and customizable option over OpenShift templates, and this was just a small demonstration of that. We do have a Gitlab package registry site for you to download any of the Helm charts that we did publish onto that. Currently, we have the Mongo Helm chart onto that, so you can download that and just analyze that and see if there's any iteration that you can bring to that. But there's also Helm chart documentation that you can follow along to create your own Helm chart potentially. And yeah, special acknowledgments to the entire Do It team. They have set the bar and as well offered a tremendous amount of support. And to the greater LLNL and Jane Harriman and Dave Fox, I appreciate speaking with them briefly. So yeah, thank you.